Hello and welcome to Noel's Retro Lab. This is not a video I was actually intending to make. I was restoring this Amstrad CPC 6128 behind me. When I cleaned it up, I got it working, and then I started looking at the floppy disk drive and I found some interesting behavior going on with it. So I figured let's pause in there so we can actually start recording this, and let's all look at the problem that this drive has and how to repair it. I was just working on this Amstrad CPC 6128. I finished cleaning it and getting it ready, so it was time to test it. I popped in a disk, I do a catalog, everything looks fine, and then I try to run something. And this is what happens, it just gets stuck. So I opened it up to look at the drive closely. When I do the catalog, the head moves correctly to track 0, but then I try to run something. It moves supposedly where that file is, and it just gets stuck in there. So here's the drive that has given us problems, and I had already serviced this. If you want to know more about just normal servicing of 3-inch floppy disk drives, check out the video in the corner, the link that I'm putting there right now. It was actually the first video I ever made for this channel, which is kind of cool. But yeah, I did all the basic stuff. I put a new rubber belt, I lubricated the guide and the worm drive, and it's just given us that weird error. Now, that's an unusual error. It reads from sector 0, which is where the catalog of the archives in the disk is, but as soon as the head moves away anywhere else, it seems to just lock up. And that just rang a bell. It turns out I have a drawer full of floppy disk drives that are actually of 3-inch floppy disk drives that are not working for some reason or another. And guess what I found? I found this other one, and I usually write down what's going on. And this one says, only reads sector 0, bad drive shaft, ? That's surprisingly similar to what's happening here, isn't it? And then what's more interesting is I flip it over and I'm like, wait, this kind of shape PCB is not the most normal thing. Are these the same model drives? And indeed they are. They're EME 156V, both of them. So that actually made me feel better about it. I thought this was just some kind of random error, like maybe the drive shaft was too worn or the motor or something. But the fact that we have two of the exact same model doing the exact same thing, I don't know. I mean, it could be just a defective model in general. It's certainly one of the newer ones that tend to be cheaper, I think, than the older ones that were heavier and more sort of bomb-proof. But the fact that they're kind of reading and kind of not reading makes me think there's something else going on. So I figured it was worth stopping the refurbing of that Amstrad and actually focusing on trying to fix these drives. So one thing I noticed from the beginning, but I didn't give it much thought, is that the head, this is the read-write head, and this is the assembly that moves it back and forth with the step motor. And I can move it by hand. There's it's not like it slides down on the worm shaft. It's just that I can move it in place. There's some wiggle in there. And what about this old one? Yeah, same kind of thing. And I don't think that's the most normal thing. Actually, I have so many. Let's bring another one and compare. So here's another one from the drawer. This one is a different model and different problem. Read error, no track 0. It's probably the track 0 detection mechanism. So anyway, so here, if I try to move the head, it doesn't move at all, as it should. So the fact that these two give me the same error and the head moves this way makes me think there's something going on with both of them that is unique to this model. CPC Wiki is probably the best place to look for technical information on the Amstrad CPC in general. They have a great section on all the different drive models with pictures and board schematics and everything. It's fantastic. And then you can search the forum for specific things, and you get lots and lots of existing threads of people asking how to repair things and very knowledgeable people responding to them. It was in one of these threads that I found Gerald, who is one of the most well-known members of CPC Wiki, and he's actually the author of the Amstrad CPC memory test program that you may have seen me used sometimes. And he mentioned that some particular drives, specifically the EME 156V models, tend to have some problems with a tab that keeps the motor in place. So that might be the problem we're having. So the metal piece mentioned in that thread is probably this tab back here. This looks, yeah, and it's kind of sticking out. Apparently the purpose of this is to hold the motor in place, and if so, wow, what a horrible design. Right, this one also has that. So yeah, notice the other one that is a very different design doesn't have that tab in there. This is solid. But yeah, this one has that tab as well, and this one is not sticking out as much, but it's certainly not pushing into the motor, so that could be it. Yeah, this one is really sticking out. So if I push it, the head doesn't move very much at all. So as an experiment, let's try loading something from this floppy disk drive while I'm pushing this in by hand. All right, I'm going to be holding my finger right there while we try to load a game. Let's see if that helps any. Yeah, check it out. It's loading it just fine. So the only sort of way that I see to have this tab go back in is to disassemble the motor completely. Now, that's a delicate operation because once you disassemble this, it's just those two screws and I think it just comes undone. Sure, we can take it out and push that tab in, but then once we reassemble it, we need to realign the drive shaft. Now, one thing that Bryce over at CPC Wiki Forum suggested was to actually clean the guide rail. Now, this one is definitely lubricated it, and I think it's fine, but it's a much easier operation than taking out the motor itself. So we might as well start in there. To remove the guide rail, we need to loosen the two screws that are pinning the guide rail down without removing them completely. And then we can slide it out with our finger or a pair of pliers, and it comes right out. There you go, they came out really easily. So it looks like it was very clean to start with. Now putting it back should be the same. We just need to make sure that it goes into the drive assembly, into the head assembly itself. There you go. And now we just tighten those screws again. And to finish it up, I'm going to put a tiny drop of oil right there so it moves freely back and forth. Let's give this a try. I'm not convinced this is going to work, but that was way easier than trying to remove the motor. So that's a nice first step. And it looks like I suspected it made no difference, but it was worth trying it. So now we have to take out the motor, fix the piece, and put the motor back in. Once you do that, you have to realign the motor. And that's the main reason I wanted to do this video in the first place. Not just for this particular repair, but many other times these kind of 3-inch drives, somehow the motor gets misaligned with the tracks themselves. And you need to realign them in order to get it to read again. So this particular procedure that we're going to do right now is not just part of this fix, but it's something that you may encounter many times with these kind of drives. And there's actually very little information about it out there. There's a few descriptions, mostly in CPC Wiki, but no other videos that I could see, especially showing what to expect and what to look for to realign the stepper motor. So let's go ahead and do that. I think it should be pretty interesting. So to take out the motor, we just need to unscrew those two screws that are holding it together. We need to be extra careful with that little PCB on the side. If you're not careful, you may bump it and actually it could break pretty easily. Once the screws are gone, we can just pull it backwards and it should just come right out. That brown thing in the middle is a magnet, and that's what rotates to move the shaft. So now we can push in that tab so it holds the motor together. Now we can go ahead and reassemble it, but it's not going to work. First, we need to align the motor. In order to be able to align the motor properly, we need to understand what the motor does and what the structure of a disc is. A disc is a circular magnetic surface, and in the case of these 3-inch floppy disk drives, they are single-sided, so if you want to use the other side, you need to flip it, but that's irrelevant for this. The disc is divided into tracks, which are rings around the disc. So the outermost one is track 0, and then you have a bunch of other tracks. In the case of these discs, we usually have 40 tracks. Then a section of all those tracks is called a sector, and the disc is divided into several sectors. In this case, there are usually 9 sectors. The disk drive, in order to read a particular piece of data, needs to go to a particular track, so it will move the read head in or out to match the center of that track, and then it waits for a particular sector to go by as the disk is rotating to read the data in that sector. The step motor is in charge of moving the read head in or out. The way it does that is not by moving itself in or out, it actually only rotates, but moves a worm shaft, which then slides the read head in or out. Let's zoom in a little bit and look at the disk from the side. So each of those areas is one of the tracks, and we have the read head under the disk. When we look at the step motor head-on, a particular rotation on the step motor corresponds to the head being at a particular track. The step motor is designed so it can only rotate fixed amounts to the right or to the left. So when it moves one step to the right, the head moves forward one step, which corresponds to a track. So we can move the step motor multiple times to seek tracks forwards or backwards. The problem is that when we take the step motor out and put it back in, the current rotation of the step motor doesn't necessarily match the center of one of those tracks. Instead, it could be somewhere randomly halfway between two of them. As a matter of fact, chances are it will be somewhere not centered. So what we need to do is very slightly rotate the step motor so that each of its positions corresponds to the center in each of the tracks in the disc. So we need to start by putting the motor back on the shaft. And it doesn't really matter the position you put it in, as long as that little PCB on the side is not interfering with the screws. Then we tighten it a little bit. The goal here is to leave it without too much wiggle room, but just enough so we can very slightly rotate it to the left and to the right to adjust it. So there, for example, it was too tight, so I need to back off a little bit and loosen it just a little bit. That seems a little better. Let's tighten it just a little bit. And that feels just right. Here's a close-up from the top so you can see that it's pretty snug, but we can just rotate it enough. So now in order to align the motor properly, what we need to do is maximize the voltage read by the head of the drive. That's how we'll know that it's aligned properly. How do we do that? We need to monitor the head itself, the output of the head, and that in this particular board is in TP2 or TP1. That's test point 1 and 2. So those are the ones right there and right there. Since they don't have an attachment or anything, what I'm going to do is I'm going to solder a cable there, and then that way I'll be able to flip the drive. So we'll just put it in TP1 for now. Like that. So now I'm able to monitor this with the oscilloscope. Okay, so what I've done here is I've hooked up the Detonator expansion board, and that's mostly like a ROM board. So it allows me to load different ROMs, which is great because we don't have a working floppy disk drive. So as soon as I turn it on, I get a menu, and from the menu I've set it up so I have disk test as number 1. For this particular test, we're going to use an official disk because this one will be authored in a way that is aligned properly. So I'm going to use one of the CPM disks that came with the computer. And we're doing this with the oscilloscope hooked up to the output of the head read amplifier. And our goal here is to rotate the motor that we just removed in such a way as to maximize the voltage here. Now, this particular voltage, I have it on AC coupling to ignore the DC component, and it's fairly zoomed in. So this is 200 millivolts per grid. So that's roughly a little under 400 millivolts. And ideally what we want is to see that as large as possible as we rotate this. So I'm going to rotate this a little bit. So I need to pick one side. It doesn't really matter. I'll go this way. I'll go that way. And it didn't make any difference because we haven't actually stepped the motor. So I'm just going to move there, tell it to do a different track, other track 15, and tell it to go to that track. And that didn't seem to change too much, so we just continue doing this. And I move it very, very little. So it seems it's getting a little smaller, if anything. Either no change or smaller, so we'll just keep doing this. Oh, there you go, that's a little better. Now we're definitely reaching, that's 400 or a little better. So I'll continue moving that way just a little bit. No, much worse. You see what a big difference that made? I'm gonna try putting it back. I'm just gonna zoom in a little bit so you can see how I rotate it. So just rotate a tiny little bit and then tell it to go to the next track. Do that, and clearly that's not very good, so I moved it a fair amount, but since we're not close to the that got a little better. It's annoying that I have to lift the keyboard every time. Yeah, it's getting better, so maybe we're getting closer. Yeah. What's that? Yeah, this is definitely better than before. Ooh, much worse. Seems like you pass it. Yeah, now it's getting worse. So that's probably as good as we're seeing it. Let's try securing the screws in this position and then seeing if that helps. I've tightened the screws in the drive shaft, so now let's try it with the same floppy disk we were trying earlier. That's great. And then can we run this? It looks great. Awesome. And to be really sure that everything is okay, we should try it with some different disks. So I'm gonna put in the system CPM disk and try to use that one. it's always good to try with several disks just to make sure that you didn't align it with one. And also, you should be using, as much as possible, standard disks, or disks that came with the system, or games that were manufactured, as opposed to disks that were saved with a floppy disk drive, which may or may not have been properly aligned. So the catalog works fine in here, and if I try to load CPM, oops. Sounds good. I don't hear any retries either. So that's really good. And there you go. So I think this is rock solid. So one question some of you may have is, so, okay, what if you don't have an oscilloscope? Can I still align the motor shaft? And the answer is yes. And actually, to a certain extent, it's even easier. So here, I'm gonna de-adjust it a little bit. There you go. So if we do catalog now, we probably won't read anything. There we go. So this is just as simple as what we were doing earlier with the maximizing the voltage, except that all we're trying to do now is to be able to read the catalog of a disk correctly. So I'm going to start moving it little by little, just a little bit, and then say retry, and then we're not there yet. And then eventually it's going to read the catalog, and it's still not going to be perfect. We need to adjust it, maybe trying a few disks, make sure that we load things instead of, I just moved it a lot. Instead of just doing the catalog, then we actually need to load things from disk because different tracks may not work correctly. But it's just like this. So obviously you need to fiddle with this for quite a while. Yeah, it's moving it a lot, so it's not really helping too much. But eventually you end up finding the right spot. And actually there are multiple right spots. I mean, it's not like out of the whole rotation, there's only one, there's many of them. I'm surprised we haven't found it yet. Oh, there we go. So notice that actually it had a couple retries and then it showed up the catalog. So it means we're close, but we're not quite there yet. So now we need to move it very, very little. Let's see. There we go. That's much better. Let's try running something. Great. So that's perfect. And at this point, I would do the same thing as I did before. I would then test it with some other disks. And if I have to, I'll make tiny, tiny, tiny adjustments to the rotation, and otherwise just tighten the screw and it's good to go. And we did it without using the oscilloscope at all. As you see, this is almost easier, and there aren't that many combinations. So it's relatively straightforward to do in 5 minutes. And there you go. We got a fully functional floppy disk drive again, so that's pretty satisfying. Now I need to do the same thing on that other one that had the same problems and it was the same model, but that should be pretty straightforward. So the really interesting thing here, I hoped you get out of it, was the realignment of the stepper motor. So I hope that was useful. If so, please give it a thumbs up and consider subscribing to the channel. Until next video, see you then.